Jose Cordova from EPRI, who's going to be talking more about 1547 that Brian highly suggested that folks adopt. And he's going to tell us how to do that as well.
Thank you, Debbie. You guys can see my screen now?
Yes, I can see your screen. Yes, that's perfect.
Okay. Okay. Yeah. Well, thank you, Debbie, for organizing this, and I'd like to thank Naruk for giving us the opportunity of sharing our experiences and all the learning that we have done here at EPRI. I couldn't think of a better presentation before making my own. Actually, I think that Ryan hit the spots of how important it's actually to have this coordination process that he was mentioning, and also how the DRs are growing in our grid. And today I'm actually joined by my colleague Jens Boomer. He will be also here, maybe even answering some questions in the chat. And I'm gonna present today about the opportunities, adoption methods, and the stakeholder coordination for adoption of 1547 IEEE 1547-2018 and its amendment that happened last year in 2020. And I would like to start first on how, as Ryan was saying, how paramount is basically 1547 for unlocking the benefits of advanced DER functions and capabilities. Actually, 1547 is a voluntary standard that basically opens what is called or establishes basically the technical interconnection requirements, or the interface between the DER and the grid. And it helps to specifying the DER performance, or establishes the DER performance and functional capabilities. And this is done by updating interconnection agreements that allow the utilization of those DER capabilities. Basically, these are the first two steps when adopting this standard, 1547-2018, that will lead into more market participation at the end of DERs, either individual or also in aggregate form. And one of the first steps was also taken from Naruk, encouraging the states to adopt this standard in order to integrate more and more DER into the grid. And well, I think that the potential impacts has been covered from the previous presentation of aggregate DER on power system reliability. And well, the main message is that any type of disturbance that may affect the frequency in a widespread disturbance in the frequency may not only lead up to any frequency disturbances, not only from the transmission side, but transmitted actually to the distribution side. Any disturbance can actually not only have an impact on the frequency, but there could be any more and more loss of DERs due to tripping responding to that disturbance. And that will basically become like a loophole, or a loop, sorry, that might end up with even more disturbances, which may actually affect directly the safe and reliable way of operating for the grid. So I think that's basically one of the potential impacts on both power system reliability. So what is the role of the standard 1547-2018? And this is really important. It defines and standardizes what DER means, and it is very important to say that DER does not only mean PV or wind turbines. Actually, the 1547-2018 is technologically neutral standard, and it actually includes different parameters for all the technologies, also including synchronous generators, for example. And it is really important to say that any type of distribution the energy resource connected to in the distribution side, it could be DER. And well, it establishes basically the technical basis for regulatory proceedings, and by giving flexibility, basically, of those, given that it is known that that no circuit is alike, and also there is no one-size-fits-all in terms of a standard that can just put any some type of parameters or settings that just do all the circuits, and therefore the standard actually gives some flexibility in that regard to adjust it to the actual needs of the different circuits across regions. And it is a standard that was widely accepted also by the industry. It was well discussed, and it had a lot of acceptance. And the value of 1547/2018 is it is to avoid those lengthy discussions with the stakeholders, and to avoid those specifying technical requirements, or avoid those lengthy discussions, basically, and account for those regional differences that I was talking about. It gives that flexibility. And at the end, all of this is or adopting a standard such as this one, what it does is basically accelerating the regulatory proceeding. And it also takes into account the mitigations of technical risks by establishing those minimum requirements for DER capabilities that at the end will ensure the reliable and safe conditions for the grid to operate. So where does 1547 fall in terms of other requirements or other standards? As you know, as you may know, 1547/2018 is not actually, it is a voluntary standard, meaning that it can only be enforced as when the authority governing interconnection requirements actually adopts the standard. And in that sense, we have different levels as seen here in the graph, where you have the national, state or public utility commission utility laws, the PUC utility laws, and we have the national codes and national requirements, such as the ones that are dictated by NERC and FERC. And only when the different states and PUC actually adopt this type of a standard, it can become enforced. So in that sense, states and PUC can adopt by adopting the 1547 base standard, 1547/2018 version. The base standard is actually joined by another standard, which is the 1547.1. And 1547.1, it basically establishes the different test procedures, to comply with the base standard, meaning that any DER equipment connected now to the grid that complies with 1547 needs to follow those steps or those procedures during testing. And who gives the seal of approval, or who certifies those DER equipment? The certification test is actually performed under another standard, the UL 1741, which in previous versions of 1547 in 2003 or 2014, actually, it was called the 1741 Supplement A. Now, for the new version, 2018, UL 1741 has a Supplement B, which gives the seal of approval or certifies that the DER equipment comply with the minimum requirements, or complies with the requirements established by the base standard 1547. Again, following the test procedures of 1547.1. So there are two concepts that I think that it's really important to differentiate. The first one is capability versus utilization. And capability is the set of functions and also the ranges of available settings that a DER can actually have. And and you can think of it as you can think of it as what type of mean of transportation am I using? You can be riding a horse, you can be driving a Volkswagen Beetle, or you can drive in a Ferrari. And that's basically what is the capability of my DER equipment. Some examples are frequency response and ride-through. And 1547, what it does is establishes what capabilities are required by DERs, meaning what I need to drive on the road. And then the utilization, on the other hand, is that enabling and disabling those functions, and also establishing the functional settings or configured parameters inside the DER that will basically tell me that determines the limits, or it gives those limits on how to perform on the field. And in that sense, 1547 establishes what is called the minimum requirements, again, for the reliable operation of the grid, by establishing some default values that can be adopted, but given the flexibility I was mentioning before, it can actually be configured in a different way that it's needed for the circuit's characteristics of the region. So 1547 establishes those limits that can be seen as basically traffic signs or split limits, if you may. And some of those examples are deadband, droop, or response time, etc., and among others inside the standard. So this is the basically this is our this is the experience learned actually from some of our members. We have seen at EPRI, we have identified that there are different 1547 2018 adoption methods. And most of our members, and also across the industry, we have seen that the first two on the left, the general reference and detailed reference, are amongst the most used so far. And then the first one, or the first adoption method that we would like to call, we call a general reference. It means that the full adoption of the standard by general reference. And this is not to be mistaken with when adopting 1547 2018, I just cited this standard and then I'm done. My job is done. And however, it is not the case. Actually, the standard comes with a series of decision points that need to be addressed and need to be discussed. Some of them, well, those are the specification of performance categories. Could be they are in the normal category, in the abnormal category. The second point is the functional settings, and this is also quite important because it tells you basically there is the need of discussing this between both transmission and distribution side in that coordination process that Ryan was talking about previously, to basically come up with what are the functional settings that will be or how my DER will perform in the field. And for that, you need, utilities need to either adopt the default values that I was talking before, or come up with their own utility required profiles that are within the allowable range of settings that comply with the base standard. And that is the flexibility that I was mentioning before. And the third point of decision is the adopting any communication protocol such as SoundSpec, Modbus, or 2030.5. And then there is the detailed reference, which is more of a, it's still a full, it could be a full or partial adoption of this standard. And it could be a reference by a clause, for example. And it also could go even beyond 1547 2018 by adding some other additional requirements. And at EPRI, we have identified that normally the TIR, the technical interconnection interoperability requirements that are drafted by utilities, sometimes they have there are some common other requirements that are on those documents, and EPRI has identified and has generated what is called the generic TIR template, which is a document that basically has those commonly required practices, and it is more of a recipe on how to draft basically a TIR. And it is going to be published by the end of the month. It is in publication process, and it will be publicly available at the EPRI's website. So it's open to public, and this detailed reference actually has the benefit of, well, first of all, consistency to the standard. And however, one has to be careful because in not fragmentizing the requirements or the clauses of 1547, because that could bring certification challenges and which can translate actually into additional cost. Which is why we identified the need of some template actually for this TIR documents. And the third adoption method, which we haven't seen much around, but we actually don't recommend it, is that you draft your own language of the standard basically, on a clause by clause, meaning that you will have your own requirements and start drafting with your own language those requirements. And this could lead to inconsistencies with the standard, and also fragmentizing those requirements. And again, it could bring certification challenges and also additional costs during certification. So in the EPRI actually recommends some steps for the adoption of the standard. It can be categorized into three categories: the interconnection, interoperability, capability, DER data management and functional settings determination, and the stakeholder coordination between distribution and transmission. One of the first steps is actually, well, determine your adoption timeline, obviously, and also alert the regulatory agencies. And initiate, one of the most important things is to initiate the stakeholder process to determine the interconnection and interoperability capabilities. And that means that if the governing authority actually, or the authority, or the PUC or state authority should begin a stakeholder process where it's either decided to follow the default values of 1547 2018, or coming up with regional functional settings, or again within the allowable range of settings that comply with the standard. And this discussion actually should always include the regional reliability coordinator, again to ensure the safe conditions of the grid. And this process, as Ryan was saying, it actually needs some balance, because some of the needs from distribution side and bulk system side, there needs to be a balance between the both of them. And at the end, the only way to overcome all these challenges is to increase the T&D coordination, to have everybody in the room and actually discuss this in a technical fashion and determine whether what capabilities or functions we need for the DER that are interconnected to the grid. Some examples of this actually are the adoption guidelines from reliability coordinators, such as for the IEEE standard 1547 2018. And here we have a map of the United States with some of the regions that are covered by some of the ISOs or RTOs in the country. And for example, we have MISO, we have the Hawaii, also HECO, and the ISO New England and PJM, which some of them, they have specified their dates of implementation, and some of them, such as ISO New England, are actually now under revision and will come up, the revision will come up in the future. But one of the main takeaways from this is that even though the ISOs might not have jurisdiction over the utilities for actually requiring these settings or these requirements, the fact that there was a stakeholder process and there was a coordination process between transmission and distribution, it actually encourages, or it is expected that utilities actually comply with those minimum requirements or requirements of the ISO's RTO. So the only way to have this is to actually have in order to get this is to actually have that discussion and have a coordination process.
So following, you've got 5 minutes left.
Thank you, Debbie. Thank you. What happens when you have a bunch? As we saw in the map of the United States, you have different regions with different requirements. They could be different, and even inside those regions, there could be even more specific regional settings. And what happens when you have hundreds, if not thousands, of those requirements? Well, you need to actually have DER data management, which is the sharing data also between the parts and between the stakeholders, also like Ryan was mentioning. And for that, actually, well, this graph here, it shows how can actually those profiles or those requirements can be determined. First, you have at the base of the pyramid in blue, you have the whenever authority governing interconnection requirements adopts what it's called the source requirement document, such as the standard 1547/2018, they may adopt it, but there could be the need of not only having the default values, but having regional values within those the compliance of the base standard. And that's when the consideration between distribution and bulk system and bulk power systems should take place, the stakeholder process. And it also it could include all the other settings that are not just the default settings from the SRDs. And then you could also go up in the pyramid and even determining or specifying even more by having a utility required only for the distribution service area. And then another could be even having a site-specific required profile, and which could be even in their interconnection agreement. And given that there might be many of those documents floating around in different regions, actually at EPRI there was a development of a file format specification that is publicly available that actually standardizes all the languages for making it easier or facilitate the exchange of those of that information, of all the functional settings of DER, and how the information flows between stakeholders such as distribution, transmission planners, planning engineers, DER manufacturers, and developers, etc., and also regulators. Also, EPRI has built a database that basically it is a website that utilities can actually upload their required profiles, where again it can be accessed by this stakeholder to understand the regional settings that are under depending on the region or jurisdiction. So, what is the timeline for rollout of 1547? As you may know, well, 1547 was published 2 years ago, and then there was an amendment on 2020, and then the .1 1547.1 was actually published also in 2020, and UL, the new certification standard, the UL 1741 Supplement B, was released last year. However, there were some challenges for the test procedures that the DER manufacturers basically transmitted to UL, and therefore there is another revision coming that will be published in around September to harmonize those or to facilitate how the test procedure should be done. And the product certification will likely to take place from September on, and most of the utilities should actually enforce the base standard 1547 2018 after that date, either April or mid 2022. And in the meantime, the stopgap solution is to actually adopt parts of the standard or using the previous supplement A of UL 1741. But the time to prepare for that is actually now. And here is a final map with some of the state initiatives, some of them completed, some of them taking place. And some of them you can see that there are already the date of implementation is there. This is where I would like to also ask the audience if whether you see something in the map that should be highlighted or is missing there, or when you start adopting 1547 in 2018 to let us know to update this map as much as possible. And with that, I think that's all I have on this. So thank you.
Thank you so much, Jose. That's a huge amount of work that you and the entire team is doing on 1547 and the accompanying UL certification and making sure the testing and everything is all together and aligned. There is a question from Jason Pauls of New York. He says that in New York, they want to adopt the IEEE 1547-2018 standard in early 2022, but we're hearing that an inverter manufacturer is not yet ready to meet the test requirement. What are others hearing on this topic? And Jens started to answer, but wanted you to clarify in your presentation further thoughts on this.
Basically, it is this problem, there were some challenges, as I was saying in the presentation, that there were some challenges from the manufacturers to actually meet or comply with 1547 test procedures from .1, and there was a revision that included also another stakeholder process inside UL. It was an open one, and they have, with that revision, they are planning to have by September. Some of those implementation dates actually from other PUCs in states were even for January 1st of 2022, but it's more likely that they will push that date to the middle of 2022 or April to the middle of 2022 because of that reason, because it was, it seemed to be that there were things that were not clear on how to do those tests from .1, and therefore that's why basically the rollout has been pushed a little bit because of that. I hope that. And in the meantime, the stopgap solution is to actually implement either parts of 1547 or adopt supplement A, which was the one that basically cover or the test procedures for California Rule 21 and Hawaiian Rule 14.
Great, thanks, Jose.